Hi, welcome to this video. In the last videos, we talked about chapter 1 of the book, okay? Basically, we introduced the differential equation, order of differential equations, whether it is autonomous, non-autonomous, linear, non-linear, whether it is an ordinary differential equation or partial differential equation, all those kind of things. Also, we mentioned that not all differential equation can be solved. And also, if one differential equation has solution, it doesn't mean that we can solve it easily. Okay, some of the differential equations are harder to solve. In those cases, you can graph the solution of differential equations by three different techniques, right? We learned phase line, okay, or phase portrait or phase diagram. That's what we say. The another method we learned was the linearization technique. We find out the equilibrium points, and then to test the stability of those equilibrium points, we did the linearization technique, and we find out whether a equilibrium point is, or the equilibrium solution is stable or unstable, and then we draw the other solution curves, right? And the other one was slope field or direction field. That's what we did in the last videos, okay? So now on chapter 2 and chapter 3, basically, we will try to solve mathematically. We will try to integrate and then solve. There are different techniques we will learn, right? We'll try to solve by hand on a differential equation and then find the solutions. Also, we'll discuss about the interval of validity in that case, okay? So there are different types, there are different methods to use differential equation based on the type of differential equation given. Okay, the very first type of differential equation that I am going to solve is first of all, let's talk about what is the first order ODE. We did that already, right? If the highest derivative used is the first derivative, then it is first order ODE. So the first order ODE can be autonomous or non-autonomous, meaning the independent variable can be seen explicitly on the right side or not seen, or linear or non-linear. Linear means the y or y prime, they are by themselves on the right hand side, not the product of y's or y primes each other, okay? Or any fractional exponents. If the exponent of y or y prime on the right hand side are, all the exponents are 1 and they are not in the product form, then or in the denominator, then that's the linear, otherwise non-linear, okay? So in this chapter, actually, we will discuss how to solve a first order ODE that includes linear, non-linear, or autonomous, non-autonomous. No worries, okay? Okay, the very first type of equation that we will try to solve is the separable equation, which is section 2.1, okay? So what do you mean by separable equation is if f of x, y, or the right hand side of this differential equation can be written in the product form of px and qy. If you can write the right hand side as the product of px and qy, what do you mean by px and qy? If you can write the right hand side as the product of function of x only, this is function of x only, either x or constants in there, and the function of y only. If you can separate the right hand side of the differential equation as the function of x only or function of y and function of y only, if you can write in this form, okay, then we call this equation is separable first order ODE. So how do I solve this type of equation is we try to move all the y terms in one side. I divided both sides by qy, and then this is what you got. And we try to move all the x term in one side. So you can write the dy over dx as 1 over qy dy equals to px times dx, right? This goes there. You can think that way. And then after you do that, we will integrate. Okay? So let us see example number 1. Solve dy over dx equals to 6xy squared, where the initial condition is given as 1 over 25. Okay, so how do I solve this? Is solution is, first of all, this can be written as 6x and then y square. It is like px and then is like times qy, right? You can write that way. So it is already written that it can be written that way. So to solve this equation, let me write down the equation first. Dy over dx equals 6x times y square. You can do that, right? And then also y at 1 is 1 over 25. So how do I solve this? Is divide both sides by y square. Why? Because I want to write in the separate form. On one side I want to write y term only, or the differential dy. On the other side I want to write x and dx form. Okay, so I can write 1 over y square dy equals to 6x dx. Now what do I want to do is I want to integrate. Okay, integrate. If I integrate, what do I get is integration of 1 over y square dy equals to integration of 6x dx, right? So how do I integrate this one? I can move this to the y to the negative 2 dy, right? And then equals to integral of, you can pull that 6 out and then x dx. That's what you can do. And do you remember the power rule of integration? It will be y to the negative 2 plus 1 over negative 2 plus 1, right? Equals to 6x to the 1 plus 1 over 1 plus 1. Why? Because the formula is this, right? The formula is integral of x to the n dx. This is n, okay? Equals to, if n is not equals to negative 1, all right? If n not equals to negative 1, then the formula for this is x to the n plus 1 over n plus 1 plus c. If there is y and y, exactly the same thing. Okay, but n, this exponent n should not be negative 1. Okay, so it should not be negative 1. If it is negative 1, it will be natural log, right? All right, so what do you get? And then you write plus c. Why do I write plus c there? The reason why I'm writing plus c, although you will get one constant plus c on the left side and another constant, let's say you get on the left side you will get c1, on the right side you get c2, and then if you move that c1 to the right side and combine those constant, you can write just a single c. Okay, so what do you get there? You get a negative, because negative 2 plus 1 will be negative, right? So that will be negative, that is negative. Let me erase this. So negative y to the negative 1, right? Y to the negative 1 equals to 6x squared over 2 plus c. Did you see that? Now what do we get here is, let me write down this as a negative 1 over y equals to 6x squared over 2 plus c. Do you know that this y is function of x, because we are, this y is dependent variable and x is the independent variable. So you can write like this. So you can write negative 1 over y, which is function of x, equals to 3x squared plus c. Now I want to find out that c. How? And use this initial condition to find out c. Using y at 1 equals to 1 over 25. What do I get? Negative 1 over y at 1. I'm replacing x by 1 equals to 3 times 1 square plus c, right? So how much is that? That is negative 1 over, what is y1? y1 is 1 over 25. I can write 1 over 25 here equals to 3 plus c. I want to find out the value of c, and I'll plug in back here, right? Or I will plug in back wherever you can plug in back here, and then you will solve it later. Okay, so for y, so what you get is this will become negative 25 equals to 3 plus c. So subtract 3, you will get 28, right? So this implies c equals to negative 28. Okay guys, so c is negative 28. So let me continue from there. So I want to plug in that thing, that c thing here. Okay, that c is negative 28 here. So what do I get is I get negative 1 over yx, okay, equals to 3x squared minus 28. You see that? So what do I get? I get Now there is 1 in the denominator, right? So I want to solve for y x or y, right? So what is the value of yx? Then you flip, right? So you get negative yx equals to 1 over 3x squared minus 28. So if you multiply both sides by negative 1, you will get yx equals to 1 over, you multiply right side by negative sign 2. You get 28 minus 3x squared. This is the solution. Okay, this is the solution. This is the solution. So we solved it. Now we need to find out determine the interval of validity. So tell me, this is the solution, right? Now where this function is not defined, the solution will not define if the denominator is 0, right? The solution function will not be defined if the denominator is 0. That means if 28 minus let me use different color for that. So the solution will not be defined if 28 minus 3x squared is equals to 0, right? If you solve for x, how do I solve for x? Add 3x squared there. What do we get? 28 equals to 3x squared. Divide by 3. 28 over 3 equals to x squared, right? So x will be plus minus root under 28 over 3. Okay, so in these 2 points the solution is not defined, but it is defined everywhere except these 2 points. What does that mean? Let us draw a line and then find out the 3 intervals, possible interval. One is negative 28 over 3 root under, the other is positive 28 over 3 root under. So the interval of validity could be one of these. Okay, the interval of validity could be either it will be left of that, go through negative infinity, or right of that, or go to positive infinity here, or the middle part. Okay, or the middle part, because at those points the solution is not defined, is not valid. Okay, so what we do here to do that is now we check the given initial condition. The initial condition where that x belongs, x equals to 1 belong in the middle, right? 1 belong here. So this is the interval of validity. So the interval of validity is the one, because there are 3 possible intervals that the solution function is defined, but the interval of validity is the one where the initial value of x belongs. 1, that is the initial value of x here. 1 belongs here, right? So that's why interval of validity is negative root 28 over 3. That root is for the whole 28 and 3. Okay, guys. So that is for that, and then through root under 28 over 3. So sometimes it may be harder, harder to solve and then find out the interval of validity. In that case, what we do, some people try to plot this. Some people try to plot the solution function. If you actually plot this solution function in your calculator, you will see a graph like this. You will see a graph like this is x-axis and y-axis, right? If you draw the graph, so let's say this is 1, 2, 3, and this is negative 1, negative 2, negative 3, right? So how much is this value? Almost. So if you use calculator for that, you will get, so 27 over 3 is 9, right? 20 over 3 is 9 point something, and root under 9 point something is 3 point something. Let me find out what is the value of root 28 over 3 in my calculator. So 28 divided by 3 is 3.06. So it is, this value is almost negative 3.06. This value is almost positive 3.06 here. So if you draw the graph of this function, you will see a graph like this. And then you can guess what is the interval of validity, because it sounds like the function is not defined outside that, because it is negative 3, positive 3. So 3.06 may be somewhere here, right? 3.06 negative will be somewhere here. So the graph is not valid outside that interval, this interval, and the graph is only inside that interval. So you can sometimes guess the graph, guess the interval of validity from the graph also. Okay, so the next thing we want to do is I want to see some more examples there. Okay guys, let's see some more examples. Let us do the example number 2. It says solve x times y prime equals to root under, oh, there is root under and 1/2. This is just root under, right? So actually this problem is from your book. This is actually question number 6 from the book. Okay, so x y prime equals to root under 1 minus y square. Okay, so how do I solve this? Is to solve this example, to solve this problem, what we do is let's write down x and then dy over dx equals to root under 1 minus y square. So you can divide both sides by x, right? What do you get? You get that goes to 1 over x, right here. So there is dy over dx equals to root under 1 minus y square over x, right? Now we want to separate y in one side and x in the other side. How do you write that? You can write 1 over root under 1 minus y square equals to, oh sorry, dy also there, equals to 1 over x dx, right? Now we integrate. What do you get if you integrate? You will get, what is the integral of root under 1 minus y square from calculus 2? It is sine inverse y, right? It is sine inverse y. So it is sine inverse y equals to, what is the integral of 1 over x? Natural log of x, right? Natural log of x plus c. Okay guys. So how do I solve for y then? This y will be, therefore y of x will be, you should take sine on both sides. You will get sine natural log of x plus c. Okay, so where x must be greater than 0, right? Otherwise this natural log will not be defined. Okay, where x must be greater than 0. That's the solution. That's the answer. Okay, let us do example number 3. So I want to do example number 3 here. Okay, so I want to do solve y prime equals to 2x y square plus 4x cubed y square, and initial condition is given as negative y1 equals to negative 2. So the question is asking to solve this. Okay, and also plot the graph of the solution. You want to plot the graph of that solution. You can use calculator for that, and determine the interval of validity. Okay, you want to find out the interval of validity for this too. So we may not have enough space here, so what I want to do is I want to use this space too, like this. Okay, so how do I first solve this? Let me write down dy over dx form here. So you can write dy over dx equals to, can we take y square out? Take y square out. You can write 2x plus 4x cubed. We don't write this all the time. We will use that only at the end after you solve. We will use these values to find out the value of c, because to solve this we'll have to integrate. Okay, and while we integrate we'll get a c, and then c is calculated by using that value. Okay, so what do I do to separate y and x? I need to move this y square. I need to divide both sides by y square, right? And I need to move this dx to the other side. So you can write like this: 1 over y square dy equals to 2x plus 4x cubed dx. That's how we can write, right? In the differential form. Now we need to integrate. Let's integrate. What do we get? After you integrate, you will get this. What is the integral of 1 over y square? We did that in the previous example, example 1. So what you need to do is to integrate this. You need to move this y square to the top. It will be y to the negative 2, right? And then what is the integral of y to the negative 2? It will be y to the negative 2 plus 1 over negative 2 plus 1. That basically negative 1 over y. That's what you will get on the left side. On this is 2 is constant. So integral of x is x square over 2, right? So the 2 and 2 will cancel out. Similarly, integral of x cube will be x to the 4 over 4. So 4 and 4 cancel out. So this is what you will get. You will get negative 1 over y equals to, you get x square plus x to the 4th. That's what you will get. And then there is again a single c. That's what you get. Now, how do you solve for y? So you need to flip, right? You will get y of x equals to, you can get negative 1 over x square plus x to the 4 plus so the next thing I want to do is I want to use this initial condition to find out the value of c. Okay, so if x is replaced by 1, y will be negative 2. So I can write negative 1 over negative 2 equals to 1 square, right, plus 1 to the 4 plus c. How much is that? This is 1/2 equals to 2 plus c, right? So what is c? This implies c is 1/2 minus 2. That will be negative 3/2, right? C is negative 3/2. That's what you get. Okay, guys. Now you plug in here. So let me plug in that thing here. So negative 1 over y equals to x square plus x to the 4 minus 3/2. Okay, guys. Now what you do is you need to solve for y. So you need to flip that, right? So what you get is y of x is equals to, you can see negative 1 over x square plus x to the 4 minus 3/2. This is the solution. Okay, now we want to find out the interval of validity here. Okay, guys, so we want to find the interval of validity. So how do I find out the interval of validity here? Is you need to plot this. You can plot this in the graph and then see for which value of x it works. Okay, guys, let me plot this in the graph and then see, because you need to draw the graph also. So if you draw the graph of this function, you will get this. That's what I got from my graph. Okay, so what you get is the graph looks like a negative 1, positive 1, and the graph is looking like this. At negative 1 it is negative 2, right, because that is the initial condition there. And then also I have a similar graph here. So see, there are 3 pieces that the function is defined here, right? This is defined, but which piece is our answer? So what are the 3 pieces? It is left of that piece, between that piece, and the right of that piece, right? So it sounds like, because at 1 it is defined, right? Maybe 0.9 or something, 0.9 or something. From 0.9 there is a vertical asymptote here, right? And from at negative 0.9 there is a vertical asymptote you can think of. So you can think this is just a guess. Okay, so it's and where that 1 falls, 1 fall on this part, right? So this is, let's say you can say negative 0.9 through infinity must be the answer, right? 0.9 through infinity. This is the graph, and then the interval of validity is 0.9 through. So you don't have to draw that part of the graph because that initial condition falls on that piece only. So, but if you want to know what is the exact, this is just a guess. If you want to know what is the exact value, what you need to do is you need to solve that, because this function yx is not defined if this is 0. You solve that. You can solve like x square plus x to the 4 plus x square minus 3/2 equals to 0. Okay, let us suppose this is like x square is u. You can write u square plus u minus 3/2 equals to 0. What did I do? I did x square equals to u. Okay, now you solve using the quadratic because this is quadratic. Okay, so u will be -1 plus minus b square is 1 minus 4ac is -3/2. A is 1, right? Divide by 2 times 1. What do you get? You get -1 plus minus, how much is that? 1 minus 4 times -3/2 will be 6, right? So 1 plus 6 is √7 over 2. So there are, so u is -1 plus minus √7 over 2. So that is basically x square, right? So what will be x then? X will be what? Root of that. -1 plus minus √7 over 2. And then there is also plus and minus here, right? So see, so which value is not defined here? If you take negative sign here, then you will get a negative number under the root. So you don't need the negative sign there. You just take the positive sign only because the negative sign will not be defined. So which value of x? So there are two values of x. One value of x is -1 plus √7 over 2, positive, and then another is negative of that. So this is the negative of that, right? So where is that? You know what? This graph is not very accurate. Actually, this was like this. Okay, instead of. So the function is not defined at this positive this point and negative this point. So this is the positive that point, and negative that point may be like something like this here. And those are the values, and which interval includes that? Well, one is the negative side, the other is the positive side. So this value is less than 1. Okay, this value is less than 1. So if you can use, you can just try using calculator. And so the right part is definitely the value. So what is the value of this? If I use calculator, I get, so if I use calculator, I get this value is plus minus 0.91, 0.91. I was writing just 9, so it is 0.91 there actually. Okay, so the function is not defined at positive 0.91 and negative 0.91. Okay, so and then which one? So in that case there are 3 intervals, right? One is negative 0.91. Okay, one is positive 0.91. So the function is defined either in this piece or that piece or this piece. So which piece contains that x equals to 1? That piece, right? Because 0.91 is smaller than 1. So 1 will be somewhere here. So this is the right piece for the final answer. Okay, guys? So that's how we got that one. So you can graph and then guess, or you can do it. But I mean, sometimes it is complicated to do by hand. Okay? But sometimes it is easy, you can do it. All right. Let us see another example that is example number 4. I think this is from the book. This is question number, let me see which question is that. I think that is question number 10. This is question number 10. This one was question number 19. This one was question number 19 from the book. So how do I do this problem? Is again you need to separate, right? So what you can do is you can move this. You multiply both sides by 1 plus y cubed. You will get 1 plus y cubed dy equals to secant square x dx. You always write dx at the end. Don't write dx secant square x. Okay. Now you integrate. What do you get? If you integrate, you will get y plus y to the 4 over 4, right? Because if you integrate each of those, integration of 1 is y with respect to dy. That's why. And then this is equals to secant square x dx. What is the integral of secant square x? That is tangent x plus c, right? So see, how do you write this? Is basically y plus y to the 4 over 4. You know what? Tangent x plus. So there is nothing to write. So because it is hard to solve for y, so you can write that as an answer. This is the final answer. So because we cannot solve explicitly for y, because there is y to the 4 and then y. So this is the final answer. Okay. Sometimes you can solve explicitly, sometimes you cannot solve. Okay guys, so let us do example number 5. So this is the final answer here. Let us do example number 5. dy over dx equals to that, and then initial condition is given. Also you are asked to find out the interval of validity. So how do I solve this first? So this is separable because y and x can be separated. So you multiply both sides by 2y minus 4. You get 2y. Let me use a different color. So you can write 2y minus 4 dy, right, equals to 3x squared plus 4x minus 4 and then dx. You integrate. If you integrate, what do you get? You get 2y squared over 2, because the integral of y is y squared over 2, minus 4y equals to what? So you get 3x to the cubed over 3 plus 4x squared over 2 minus 4x plus c. This is what you get. Okay. So here you get y squared minus 4y equals to what? X cubed plus 2x squared minus 4x plus c. Now I want to use this given condition to find out c. Okay, so how do I do that? Is so replace x by 1 and then y by 3, right? So 9 minus 4 times 3 equals to 1 plus 2 times 1 is 2 minus 4 times 1 is 4 plus c. What do you get? 1 plus 2 is 3 minus 4 is negative 1 on here, right? This one is negative 1. And this one is 9 minus 12 is negative 3. So what you get is c is negative 2, right? What do I get is, I get, let me plug in here, y squared minus 4y equals what? X cubed plus 2x squared minus 4x minus 2, right? So this is not easy, right? This is not very easy because it is hard to solve for y. But we need to find out the interval of validity. To find out the interval of validity, you need to explicitly solve for y. How do I solve? So you can think of like this. You can bring everything on the left, like y squared minus 4y minus x cubed plus 2x squared minus 4x minus 2. Okay, equals to 0. So this is quadratic in y. There is y squared, there is y, and there is no y, right? So if you solve this quadratic equation, then you will get y equals to negative b. This is like a, b, and then c, right? Because this doesn't have y. So negative b is positive 4 plus minus under the root b square is 16, right? 16 minus 4a is 1, c is the whole thing. What do you get? C is 2x cubed plus 2x squared minus 4x minus 2. Divide by 2 times 1 is 2a, right? So let's do this. So I want to do 4 plus minus. This 4 is common to both up inside the root, right? So if I take this out, it will come out as 2. What is left? I'm taking out 4 from each terms there. So 4 minus, let me distribute that negative sign, x cubed minus 2x squared plus 4x plus 2. This is what you will get. Okay guys, and then divide by 2. Now you distribute that, split that denominator. What you get is 4 divided by 2. There is yx, right? Is 2 plus minus under the root. So 2 plus minus under the root, what do you get? Is this will be, by the way, this will be plus, right? Because b squared minus 4ac, right? There is minus, c is negative of that. So this will be plus as well. So this will be plus, and these two will be minus and minus, right? So this and that will be minus. So this will be minus, this will be minus. Okay guys, so what do you get? So you'll get 2 plus x cubed plus 2x squared minus 4x. This is what you get. Now, which one is the right choice, right answer? Either plus or the minus. It cannot be 2 because we have used the initial condition already. So it must be only one answer. So which one is the right answer is you need to check by plugging in that. Which one satisfies? Let's plug in 3 for y and then 1 for x. Which one give you the right answer? So if you do 3 equals to 2 plus minus under the root 2 plus 1 because 1 cubed is 1 plus 2 minus 4. If you take plus, okay, let me complete this. What do you get under root? So 3 equals to 2 plus minus under the root 2 plus 1 is 3, right? Plus 2 is 5 minus 4 is 1. So this is basically 1, right? So if you take plus sign, you will get 2 plus 1 is 3. If you take minus sign, you will get 3 equals to 1. So plus is the right answer. So the minus, you don't need the minus 1. So what is the final answer then? The final answer is y of x. Let me write down this color. So y of x equals to 2 plus under the root 2 plus x cubed plus 2x squared minus 4x. Okay, guys. So this is the final answer. Now the next thing you need to do is you need to find out the interval of validity. So what you need to do to find out the interval of validity is you need to graph it, right? If you graph this, you will get, if you graph this function in your calculator, you will get so you will get like -1, -2, -3, and then +1, +2, +2, +4 like this, and you will get a graph like this. You will get a graph like, you can try graph, okay, and then this value on the right side of that will be the basically the interval of validity, because the graph is defined everywhere right of that. What is that value? Is -3.37. This is -3.37. So the interval of validity is -3.37 through infinity. Okay, this is the interval of validity. You can look at the graph and then you can move your cursor in the graph on the very last point, and whatever that very last point in your calculator is the left bound of this x value. Okay, so this is the interval of validity. Okay guys, thank you.